GATE CSE 2023. Consider a sequential digital circuit consisting of T flip-flops and D flip-flops. As you can see in the diagram, there are two T flip-flops and one D flip-flop. CLKIN is the clock input to the circuit. So here is our clock input, which is given as clock input for all three flip-flops. So it is a synchronous sequential circuit. At the beginning, Q1, Q2 and Q3 have the values of 0, 1 and 1. Here Q1 means output of first flip-flop and its initial value is 0. Q2 is the output of second flip-flop and its initial value is 1. And for the third flip-flop, Q3 is also 1. It is given in the question as the initial value. Which one of the given values of Q1, Q2, Q3 can never be obtained with this digital circuit? That means after the initial state, we are going to apply the clock pulse one after the other. When we check the next set of states, one among the given states is not going to appear in future. Only one. We need to identify the state which is not going to appear after applying set of clock pulses. To solve this problem, let us go for a state table. The state table contains the clock sequence we are going to apply. And before applying the clock pulse, the initial stage is given in the question itself. Value of Q1 is 0, Q2 is 1, and Q3 also 1 is given here. Now, when we apply the clock input, we need to know the inputs, right? Then only the flip-flop will change its state. If you consider the first flip-flop, the input we name it as T1, which takes the input from the last stage, complemented value of last stage output. So Q3 bar output of last flip-flop complemented becomes input for the first one. So we call it as T1 equals Q3 bar. Similarly, for second flip-flop, let us call this input as D2, which takes the output of Q1. So D2 takes output of Q1 as input. Similarly, the third flip-flop, which is a T flip-flop, its input we name it as T3, which takes the input from second flip-flop. So we call it as Q2 as the input for the third flip-flop. So here Q3 bar means the previous state of Q3 is 1. Its complemented value is 0, which is acting as input. The second flip-flop, which takes Q1 output, the present state of Q1 as it is, its value is 0. And the third flip-flop, which takes Q2, that means the second bit, which value is 1. We can easily understand that these two bits, Q1 and Q2, are directly given as input for second flip-flop and third flip-flop as inputs. Now, when we apply the clock pulse, we need to calculate the next state. The first flip-flop is having T input as 0. Whenever T input is 0 for a T flip-flop, it is not going to change its previous state. So previously its value is 0, so it is not going to change its state. For second flip-flop, D flip-flop, irrespective of the present state, because the input is 0, the next state also 0. The third flip-flop, T flip-flop, which has the value of 1, it needs to toggle the present state. Toggle means present state is 1, it is going to 0. So present state, after applying the clock pulse, we get 0, 0, 0. Now it is going to appear as input for all three flip-flops. The first flip-flop takes complemented value of third one. Second and third flip-flops takes the first output, flip-flop output, and second flip-flop output. Now we are having the T input as 1. It needs to toggle the present state. So 0 becomes 1 in the first flip-flop. Second one, D flip-flop, we need to consider that as the next state, because D flip-flop means the input becomes your next state. And third one again T3, it is 0. Because it is 0, it need not change its present state, because earlier it is 0. We are going to maintain 0 as our next state. So 100 becomes our next state after applying the second clock pulse. Now we are going to consider these as our input. When we apply 0, the 0 becomes 1 for first flip-flop, and 1, 0 simply given as input for second and third flip-flops. Now first flip-flop, T flip-flop takes 1. So because first input is 1, it needs to toggle. It is going to change to 0. Second flip-flop, T input is 1. It is going to be the next state. And the third flip-flop, which is having 0 as the input, it is not going to change its previous state. So 0 is the present state. It becomes our next state. So in this way, our 0, 1, 0 becomes our next state. Now complementing the third bit, we take the first input and second flip-flop input, third flip-flop input. Under this condition, we get the next state like this. And the set of inputs are calculated in this way. Finally, we have 1, 1, 1, which produces inputs as 0, 1, 1. Now, our first input is 0. For this flip-flop, T input is 0 means no change. Present state is 1. No change means first one becomes 1. Second one D flip-flop, because it is 1, the next state also 1. Under this situation, because third flip-flop is having 1, 1 means it must be complemented to 0. Now this is our new state. Now calculating the next set of inputs. This third state must be complemented and given as input, so it becomes 1. And the rest of the 2 will be given as input for second and third flip-flops. Under this situation, because T input is 1 for the first flip-flop, we need to complement the first bit, so it is going to be 0. And D input must be followed as next state for the second flip-flop. And third one, T flip-flop takes 1 as input, so we need to toggle, it becomes 0, 1, 1. If you compare this particular state, the 0, 1, 1 is same as the first one. So if you are going to apply the next clock cycle, it is going to repeat from first again. If you consider all these sequences, none of the states are repeated, right? The state values of Q1, Q2, Q3 are never repeated. Once we reach the 7th clock pulse, it comes to 0, 1, 1, which is same as our first state. So hereafter it is going to repeat after applying every clock cycle. Now the question is, there are some values given for Q1, Q2 and Q3. And we need to identify which one never obtained. So under this condition, if we consider the first one, 0, 0, 1, you check the state. Does it go to 0, 0, 1 at any time? So under this particular verification, the first input, it is not appearing. Let us check the second one, 1, 0, 0. 1, 0, 0 appears at the second clock pulse as next state. 1, 0, 1, which appears as next state in the fourth clock pulse. Similarly, 1, 1, 1, which appears in the fifth clock pulse. So except the first sequence, which is nothing but Q1, Q2, Q3 are having the values of 0, 0, 1, which is not going to appear at any time, even if we continuously apply the clock signal. So option A is the correct answer. Thank you.